Well, welcome again. This is the part, the lecture 2, slides number 12 till 21, which was missed out in my earlier recording. I apologize for that. Some glitches happened. Now I'm putting up the re-recorded one. Okay, we stopped somewhere at the basis risk. Recapping, what is basis risk? The term basis risk refers to the difference between the spot price of the asset being hedged, the underlying, the real physical asset, against the futures price in the futures contract underlying. For example, let's say we're going to hedge gold. Assuming that there's no futures contracts for gold, which is expiring at that certain period of time which I want. So I use silver. Silver futures. Using silver futures for hedging gold price. See, silver futures. Here, gold price. They are two different things. So this is where at the expiration time, let's say we are using it for, let's say, June expiry futures. For the June expiry futures, I want to buy or sell the physical gold, but I'm using futures price to hedge. So at the terminal time in June, I may look at it, spot price of the gold and the futures price at that day for the silver may be different. So when you minus spot price of the gold and futures price of the silver, it will be non-zero. That means the basis is persisting. It is there. That is where the basis risk comes in. For a perfect hedge, if I'm using gold to hedge against, if I'm using gold futures to hedge the real gold, the basis should be zero. No basis. At the time T, at the time of the expiration, let's say June contract, the spot price of gold and the futures price of the gold will converge. So what is the difference? Let's say 1 minus 1 is 0. So there is no basis risk. If I have 2 minus 1, then there is 1. There is not a 0. So the basis risk arises when the uncertainty about the time t, that is ft minus st, that is a futures price at the time t of that underlying, against the spot price of the t terminal time of a different commodity, will create basis risk. So that's why we can summarize there are two reasons for this. Number one is the commodity mismatch, as I told you. Commodity mismatch basis risk is that you're using different commodities, different underlying in the futures against to hedge a different physical underlying. Let's say grade of the commodity underlying in the futures contract may not be the one being hedged. For example, you want to buy jet fuel after 3 months. And you're afraid the price will go up, but you want to hedge it by using jet fuel futures. But looking at the market, there is no jet fuel futures. So you are selecting the one with a very highly correlated is a heating oil. So you are using heating oil futures to hedge jet fuel price. Certainly, this is a commodity mismatch. Like what I told you just now. To buy and sell gold, you're using silver futures. Or sometimes for corn, you use wheat futures. Something like that. That will create what we call it as commodity mismatch. That's the first reason why basis risk persists, and we call this commodity basis risk. Number two reasons I told you. This is the second reason. Delivery mismatch. You know very well, futures contracts are highly standardized according to the expiration. So standard maturity dates for the futures contract may not be the desired date of your hedging purpose. Example, there is no gold contract expiring in April. All gold contracts are expiring in June. And you may have to search a kind of underlying which has got an expiration in April so that you can you can close out by April and use the difference or gain or losses you got in the futures market to offset the a different underlying, which are like gold underlying, which has got June expiry. So this creates a delivery basis risk. So we said delivery mismatch. One is commodity mismatch, another is delivery mismatch. These are the two main reasons which could cause basis risk to persist even at the delivery date or maturity date. In the presence of the basis risk, a perfect hedge is impossible. We cannot say the hedge is perfect when there is basis risk existing. So what can we do? This is a problem which has been going on, let us say. Handling basis risk, okay, the idea, the concept, let's say. The question, what do we mean by best hedging strategy? Well, whether you want to cover yourself fully against this COVID, I see some people using the gloves, long sleeves, mask, helmet, and a long dress, shoes, just to go to the supermarket to buy things. They are considered to be fully covered. Some people I see just they use face mask only. No gloves, nothing, they walk freely and thinking that they won't be infected. A good example, right? Right now, what is going on? So, how you protect yourself against COVID virus being touched to you? So, some fully covered, overly covered, some just perfectly covered. So, here also we are talking about what is the best hedging strategy in the when we have a commodity mismatch. How many contracts of the underlying in the futures should we buy or sell in order to cover a certain amount of price variance in the real market? The answer is the one that minimizes cash flow variance at time t. Don't underestimate this concept. This is a very, very insightful concept. Similar to the mean variance optimization in the Markowitz portfolio theory, how do you diversify in the sense that you reduce all the standard deviations? Cross-hedging between highly correlated underlying asset, you remember carefully, highly correlated underlying asset. What is the correlation? Price of the spot, changes in the price of the spot price, and the changes in the futures price of the underlying which you're using must have at least about 70 to 80% correlation, high correlation. Highly correlated underlying assets and the asset price being hedged is the one of the best possible strategy to overcome or to reduce the basis risk. You can't eliminate the basis risk 100% when you have these two issues of a commodity mismatch and the delivery time mismatch. You can reduce it as much as possible. That's why we say optimal hedge strategy. Optimizing it. Let us see. Choice of hedging with futures contract. The choice and availability of the underlying asset in the futures contract can affect basis risk. Whether any physical asset you want to buy, whether there is a possible futures for that is important. Like when you're talking about wood, a certain grade timber is available in the physical market and you want to buy it in the futures date and you are looking for a futures of that particular grade timber, it may not exist. They may have something else. So how do you choose which futures contract you want to use? You can choose the futures which has got a high correlation with the asset price which is being hedged. This is known as cross hedging. What is it known as? Cross hedging. In some cases, the choice is obvious. In some cases, you have to ask your broker to search. Okay, use crude oil futures to hedge jet fuel. This is quite common. Using SPI index to futures index to hedge diversified Australian stock portfolios. In others, addition has to be made. Different grade of wool, wheat, coffee, or corn. Grades again. Within the asset itself, There are several grades. Whether you can get the features for the exact grade or not, we don't know. But so you have to use something close by to that. How do you say is close by to that? Is highly correlated. Government bond features to hedge corporate bond portfolios, for example. So and so on. In all the above cases, the next issue is the choice of the delivery month. One, we are talking about the commodity mismatch. The other thing, whether both has got the same delivery month. Where let's say you have an idea of purchasing, uh, let's say, jet fuel in May, and do you have, let's say, there's no futures for jet fuel, you may choose maybe crude palm oil. Does it have a contract expiration which is slightly longer than May? If it's expiring in June, perfect. You can close out in May. Let's say that you have one crude palm oil contract which is expiring in April and the other is expiring only in September, too far away. You can't choose also. So the next issue is how to choose the delivery month. Let's say. Now, cross hedging occurs when the two assets are different. That is, the asset being used in the futures contract to hedge is different from the underlying physical asset. As I've been telling you so many times, gold and silver, jet fuel, and crude oil, or palm oil against coconut oil, and so on. The physical asset is different than the asset underlying the futures contract. Let's say, for example, different grades of cocoa or different grades of coffee, or generally coffee against tea. You want to buy or sell coffee in certain future times, but there is no futures for that. You may have the tea futures like that. Since the two assets are different, their prices will not be perfectly correlated. There won't be one. The correlation can never be one. But we try to choose the one which has got a high correlation. Need to determine the optimum hedge ratio, OHR. How many futures contract to take given the amount of physical assets to hedge. That's why I tell you whether you want to overcover, undercover, or perfectly cover. Choice of hedging contracts. Now, choice of the delivery month also affects basis risk. I told you, assuming that generally almost all the futures have got March, June, September, December expirations. Then there is a rule of thumb to choose the gap. Basis risk increases as the time gap between the expiration and the delivery month increases. Let's say you want to hedge for May 20th, for example, and you want to use an underlying in the futures contract which has got a June expiration, is good enough. But let's say you don't have June expiration and you want to use September expiration. Wow. The higher, the longer the delivery months from the date of your physical asset use for hedging futures which has got a very long time to expire, that is going to give you a problem. The basis risk will increase because we have got two concepts which we will learn later. That's one is contango, the other one is backwardation. Whether the longer the time for the futures to expire, whether the price will be going down or going up, is again an issue. Rule of thumb is choose the contract whose delivery month is as close as possible, but later than the hedge expiration. You cannot choose where the futures expire first, then you want to use it for hedge. No way, that is impossible. That is like putting the cart in front of the horse and asking the horse to push. That won't work. You must have the futures which is expiring little later than the time of your hedge date. The optimal hedge ratio or the optimal number of hedging contracts and the hedging effectiveness has got a very high relationship. The best choice of cross hedging is to identify the optimal hedge ratio. We will study now. Optimal hedge ratio. There you are. Cross hedging and optimal hedge ratio. In this slide number 17, you look at it very carefully. Optimal hedge ratio, the proportion of the exposure should be optimally to be hedges. We have got a hedge here. There's a hedge index here. H equals to the rho, that is the correlation factor, times by standard deviation of the spot price for last few months taken retrospectively, divided by the futures standard deviation of the futures price. The small sigma s is the standard deviation of the change in the spot price of that particular asset which you want to hedge. The change in the spot price during the period of the hedge time. And the small sigma f is the standard deviation of the change in the futures price of the futures contract which you're going to use for hedging this particular physical asset. And this rho, we call this rho, it's not a P, it's a rho, is a coefficient of correlation between the changes in the spot price and the changes in the futures price. When the rho is 1, no, nothing to worry. There's no basis. Why? Because it's perfectly correlated. And that's why when the changes of the spot price and the changes of the futures price is same. So then you will have a H1, which means that, which is what you want to expect if the futures underlying asset and the physical asset are same. We have got an issue only when they are not same. Okay, how do we handle the optimal hedge? Some issues. Look at here, the inputs. The data inputs are here. Optimal number of contracts. QA is the size of the position being hedged, that is in units of volume. QF is a quantity, size of the futures contract. Each contract, how many size? Value of the futures position is being, VA is the value of the futures position being hedged, that is equal to the price of the quantity of QA. QA times price, you'll get the value of the position being hedged. VF is the value of the one futures contract. That is futures price times the futures contract value, the quantity. And now we have got two issues here. Many students used to come and ask me, sir, what is tailing, not tailing, this and that. Optimal number of contracts, if no tailing adjustment, you know tailing in the normal curve, normalized curve, we have got a central tendency there. And the tail, if you have got a fatty tail, that means it is not properly adjusted for tailing. So here there's no issue. Anyway, if you are using quantity, then is no tailing. H you would have calculated already, like what you saw earlier. H times QA, quantity of the position being hedged, divided by QF, or QA divided by QF times H, or that is the optimal number of contracts. You will get the number of contracts which you have to use. We'll see in the example later. Optimal number of contracts with the tailing adjustment, that means you use the value. H times VA, that's the value of the position being hedged, divided by value of the futures. That's it, easy. Now let's see here for a good example. An airline company expects to purchase 2 million gallons of jet fuel in 1 month's time and decides to use heating oil futures for hedging. Look at that. Jet fuel, heating oil, the futures is heating oil futures. Physical asset we are hedging is airline expecting to buy jet fuel, and you are using heating oil. Data is you are going to have the standard changes of the spot price of the jet fuel and the changes of the futures, that is heating oil futures, over the last previous 15 months. So what you got is, this is given usually in the exams, we give you this question, we give you this data. The standard deviation of changes in the spot price is 26.3%, roughly about it's about 2.63%, not 26, 0.0263%. So a very small change, standard deviation. The standard deviation of changes in the futures is about 3.13%, and the correlation is 92%. Wonderful. We have very high correlation, 92%. What is the value of this optimal hedge ratio? H. What is the value of this optimal hedge ratio? How many contracts? The solution is H equals to rho times by Q, standard deviation of the spot, divided by standard deviation of features. It's all given here. Just plug in the figures. 0.928 is the rho, that is the correlation factor, times by 0.0263 is the standard deviation of the spot, times by divided by 0.0313 is the standard deviation of the features. You got 0.78. Okay, what does the 0.78 means? The airline should use the number of features contracts such that the underlying value of the heating oil in the contract is about 78% of the value of the physical jet fuel. So you don't need to go and buy 100% of the contracts, dollar to dollar value. You just have to buy 78% of the jet fuel uh, value in the futures of the heating oil. That's the meaning here. Now, looking at that, we already got 0.78. Optimal number of contracts. How many? So you need to have plug in all the figures which I gave you just now. Let's say heating oil contract is a standard NYMEX is 42,000 gallons per contract. That won't change. But you're going to hedge against 2 million gallons of jet fuel. Heating oil per contract is 42,000. Jet fuel you're going to buy and sell for 2 million gallons. So therefore, you use this equation. That is the number of optimal hedge contract is N asterisk is 0.78. You already got it as H just now, times by 2 million. That is the volume or quantity which you're going to use for hedging the physical asset, that is jet fuel, divided by the heating oil per contract size is 42,000. There you are, 42,000. So 0.78 times 2 million divided by 42,000, you get 37.14. Usually about 37 contracts. Now, how do we calculate adjusting to the tail, the daily settlement? When we incorporate the effects of daily settlement, the optimal contract becomes, there you are. Earlier, you used quantity in a very general basis. Now, when you use the value, it takes into account for the daily settlements. You don't need to go for the daily rates, but it presumes inside. The number of contracts, when you use the value, is just same. H asterisk, that is the optimal ratio, times by the value of the spot divided by value of the futures. So VA is the value of the physical asset, that is the jet fuel. VF is the value of the underlying asset, that is the heating oil. Therefore, continue the example of this. You see the heating oil futures price is, let's say, $1.99 per gallon. And the jet fuel is $1.94 per gallon. Then the optimal hedge ratio with the tail adjusted is 0.78 times 2 million times the price of the jet fuel, that is 2 million times 1.94 divided by 42,000 gallons is the one contract size of the heating oil times the heating oil price. If you times it all, you get 36.21. Earlier you got it as 37 contracts, now you are getting as 36 contracts. There's just a very small difference there, but still it makes sense. Here, what you need to do is to buy 36 contracts of the heating oil futures to cover your $2 million gallons jet fuel hitch. That's the meaning. Okay, so we have successfully filled in the gap of the missing slides in the earlier recording. Let's continue with the next section. Thank you very much. Right.